Would you like to truly understand the QuickSort algorithm? In this video, we have two examples and show these in Python code. We not only explain each stage, but we use print statements in the code so you can see these stages. So you not only understand the algorithm, but also how the code works. The code is broken down into two parts. First of all, it's the moving of numbers, and second, we look at applying the divide and conquer part, which includes how you choose a pivot, which you'll see is important. Are you ready to learn? Let's go. Now the theory is, if we have a number, if the numbers to the left are lower and the numbers to the right are higher, and we can do that with all the numbers, then we have a sorted list of numbers. So imagine if we have a list of numbers. We could choose one number, which we will call a pivot, and then move the lower numbers to the left of that and the higher numbers to the right. So what does this mean? Let's choose a pivot 4. Now, lower numbers to the left, higher numbers to the right. Now it's divide and conquer. So we will take the left hand side. So we choose a pivot 2, lower numbers to the left, higher numbers to the right. Right hand side, choose a pivot, lower numbers to the left, higher numbers to the right. So we end up with our sorted list. So how do we do this? Well, first of all, in this example, the pivot's the first number, which is 7. Now, we're going to have this position where we're going to move along the list, and we want the lower numbers before this position and the higher numbers after. And that means the lower numbers than the pivot, lower than 7 or higher than 7. So have a look at this example. So here we've got pivot 7 and the lowest place you can see in the box. Now we compare 7 and 1. Well, 1 is lower than 7. So here we're just going to move the lowest place onto the number 8. Now the number 8, we compare that with 7. Well, that's not lower, so we just move on. Compare 7 and 4. Well, 4 is lower than 7, so we need to move and swap the 4 and 8. So again, we move on to the lowest place, compare 7 and 3. Well, 3 is lower than 7, so we need to change the 8 and the 3. So we do. We move the 3 to the lowest place, so now the lowest place will move again with the 8. Compare 7 and 2. So 2 is lower than 7. So again we have to swap the 8 and the 2. So that way we can see that the higher number 8, or the higher numbers than 7, which in this case is only 8, has moved to the end, while the lower numbers, lower than 7, 1, 4, 3, 2, are now in the lowest place or lower. So can you see that we've got the lower numbers than 7 and the higher numbers of 7. So what we need to do now is, with that 2 in the lowest place, we swap it with the pivot. So now we've got the lower numbers from 7 in front of 7 to the left and the higher numbers to the right. Now we can do that on the left hand side and the right hand side. So in round 2, we're looking at position 0 to position 3, so basically in front of the 7. So in this example we compare the 2 and 4, the 2 and 3, the 2 and 7 and the 2 and 8. Well, that doesn't actually make any difference. So all we do in this case is we swap the pivot in the lowest place, the 2 and the 1. So we end up with the 1, 2, 4, 3, 7, 8 after this round. Now the second part, 7 and 8, has no change. Now, the third round, we're looking at positions 2 and 3. Which are the numbers 4 and 3? Well, we don't need to swap them, and at the end, we swap the pivot and the lowest place, and we end up with our numbers 1, 2, 3, 4, 7 and 8, which is our ordered list. Now, how good is this sorting algorithm will depend on how you choose the pivot. So here we've looked online and it says a quicksort algorithm will always aim to choose the middlemost element of its pivot. Some algorithms will literally select the centermost item as a pivot, while others will select the first or the last element. Now we prefer the approach of actually choosing the first, last and central element and seeing which one of them three is the middle number. That means if you've got something at the end of the list, at the beginning or the end, and you use that as the pivot, it's very inefficient. In our last example using the 7, it wasn't very efficient. So this is one way we can do it. So let's start off looking at our code. So here we have the code where we're going to order the numbers. So we've got a list, we print it, we order it, we print it again. You can see we've got the pivot in the first position and also the lowest position. So we're going to loop, and you can see in the print statements the output we compare. So the pivot 7 compare with 1, and then the position moves to where the 8 is. We compare the 7 and the 4. We swap the 4 and the 8. You can see and compare the 3 and the 7. So we now swap the 8 and the 3 and compare the 7 and 2. Swap the 2 and the 8. So there we have our list, and at the end we swap our pivot, which is the 7 with the 2, so the 2 goes to the beginning. Now in our second example we use a longer list. The code is identical, we haven't changed the code, but now you can see obviously the output is going to be different, but we can use this output to see the different stages. So again we choose the pivot at the beginning, in this case number 5. We have the lowest position as we did before. We're going to loop through the list, and remember we're going to take numbers that are lower than the pivot and move them to the lower place. Okay, let's see the example. So here we have our numbers and we have the printout from our code. So we can see here we have our lowest place and we have our pivot. Now we're going to compare the 5 and the 3 and we move it with the 9. So now we have our lowest number 3. Now we keep moving along. We compare the 7 and the 8 with the 5. And now we get down to comparing the 5 and the 1. So when we get to the 1 we compare it with the 9. We need to swap that. So we have the 1. We move our window, the lowest position, compare 5, 6, then 5 and 4, we need to swap the 4 and the 7, so we can swap the 4 and the 7, 4 and 7 swapped, so lowest number 4, and now we're going to compare the 5 and the 2, now the 2 will be swapped with the 8, so now we have the 2 in the correct place, and then finally when we move to the last 0, which is lower than 5, we need to swap it with the 9 in the lowest place, so we swap there. So now we have our numbers which are lower than the pivot 5. So now all we need to do is we need to swap the pivot and the lowest position, the 0 and the 5. So now we have our numbers 0, 3, 1, 4, 2, which are lower than our pivot 5, and higher we've got 6, 7, 8 and 9. So that's how we moved the numbers lower and higher than the pivot. Now we will have to change our code. At the moment it's just for one pass. So to change it so we can use it throughout the list, we need to change it so we add low and high positions. A pointer to the beginning at 0 and at the end, which will be -1 from the length of the list. So length is 6, position index 5. So we go through our code and we change the zeros to lows and the end to high or high +1. So that means our code will work when we do the divide and conquer. We need to get the index of the pivot, beginning, end or middle. So we get the 3 values and now we have to decide which one we're going to use. So we get the midpoint first of all, then we've got the three values, sort them, and then the middle one is the one that we're going to use. But we don't want the value, we want the index. So there's a couple of ways of doing that. The index we can just use if else. The middle one you can use the mean, or you can sort a list and just use the second element. So there's three elements, so the index 1 will give us the middle index, whichever approach that you want. Now we add our get pivot index code. We know our order code will work. So to finalize our QuickSort, we need to add the divide and conquer part, which is essentially saying the beginning is low, the middle will be high for the first half, and the middle to the high will be the second half. So the lowest position we've called split in the QuickSort code, in the QuickSort function, and that will give us where the pivot has been moved to. So that's our divide and conquer, and you can see when we run the code, we've kept our print statements in. You can see that it orders the number, and you can see we can split each round. We've put that in the print statement as well, so we can look through the code and check it has correctly done each stage as we've described. So that's our QuickSort code. If we want to check our code, we can look at the second example, so we can change the list to the second example, and when we run it, you can see we've got our ordered list. So that code works correctly. If we want to look through all of the stages, we've left the print statement in there so we can see all the different rounds and the comparisons and the swaps from our original list through each round. So just have a look through the code if you wish, the output, to see if it does what you think it does. And eventually we come to our final result, which is the sorted list, and that's correct. So here's the code in its entirety. We got the pivot index, we ordered the numbers by our approach that we've explained, and we've got our divide and conquer part of the QuickSort. So that's our way of writing and explaining the QuickSort sorting algorithm in Python. There is a great new opportunity for anyone interested in learning about Python or any other areas of computing. In the next year, new courses will be added to the Alps Academy, and they will be available to you for free. Written by university professors, they will be specifically designed for international students, which means they'll be easy to understand using simple language. They will even be helped to improve your English if you're interested. How can this help you? Well, leave a comment. Any suggestions you make could be turned into a course. Motivated learners deserve equal access to opportunities. Help us to help you.